So let me go with some experiments. Okay, first let me explain you some of the basics. This is what we call as a trainer kit. Okay, so look at this trainer kit. So this is where you're supposed to make an experiment. You're supposed to use this trainer kit. So first you need to know what are these things first. Okay, so there's a power button over there. Here it is power on and off. Okay, so then so these things, this black, okay, we call them as inputs. If you want to give the input, the wire has to be connected to here like this. So this is a wire, okay, we call it as a patch cord. If you want to give the input, like you're supposed to connect like this, you're supposed to insert like this. Okay, if you want to give the output, you're supposed to connect to here. Red buttons are outputs and black are inputs. Okay, and this is what we call as latch. Okay, we have 4 latches here. So okay, and this is where you're supposed to insert the IC. This is where you're supposed to insert the IC. So for example, if you go with the truth table of which gate is 7432. Okay, the truth table, this is 7408, right? The gate 7408 is AND gate. Okay, you need to search an AND gate. This is okay, wait. So this is how the IC looks like. This is 7432. This is 77151. Okay, here it is. So this is your IC. Okay, this is how it looks like. So you can notice here. Can you see there? They have written HD74LS08. Okay, so LS refers to large scale integrated circuit, MS refers to medium scale, and small scale, SL refers to small scale. Okay, like that. Okay, you can notice here it has been written like this: 74LS08. Okay, 7408 is something AND gate, right? So this is the IC looks like. You can notice here we have a U-shaped knob. Okay, on one side of the IC you can notice an U-shaped knob. So while you are inserting the IC, you should make sure that this U-shaped knob should be always at the top. You are not supposed to insert the IC like this. Okay, you are always supposed to insert the IC making this U-shaped knob towards the top position. Okay, these are the pins. Look at this. We can count how many pins are there on one side. Count this: 1 2 3 4 5 6 7. So we have 7 pins on one side, and other side also 7 pins. So this is totally 14 pin IC. Okay, 14 pin IC means you can notice here we have 1 2 3 4 5 6 7 and 8 9 10 11 12 13 14 like this. Okay, if you take like this, if you hold the IC like this, you should start from here. This is 1 2 3 4 5 6 7, and this side this is 8 9 10 11 12 13 14. Okay, so these are 14 basic pins like AND gate, OR gate, NAND gate, NOR gate, basic gates. Okay, these gates will be of 14 pin. Okay, always it will be of 14 pin IC. Okay, if you want to that is with respect to ICs, and I just told these are the latches where you are supposed to insert the ICs. Okay, and this is where you are supposed to supply the power, plus 12, minus 12 voltage, plus 5 voltage. If this is not working, you can use this device. You can notice here plus 12. This is COM plus 12, minus 12, all those things. If the trainer kit is not working properly. So this is completely logic design. We are going to deal with the wires. Okay, the thing is, sometimes what happens, even though you have written properly, you have made connections properly, if you are unlucky, then there might be chances you might not get the output. That is just because this trainer kit might not be working properly, or some of the wires we call them as patch cords. These might not be working properly. They might be damaged, or this IC might not be working properly. It might happen. Okay, so be confident on what you are doing. If you are confident about the connections you have made and the design you have made, then you need to keep on checking. If you are not getting the output with one IC, then change the IC. If you are not getting the output with the voice, keep on checking the voice whether they are good condition or whether they are bad conditions. If this trainer kit is not properly working, then you can switch to any other trainer kits like that. We will be having multiple trainer kits. You can switch from one trainer kit to another kit. You can ask the examiner, so I just want to do this experiment in another trainer kit. I have a doubt on this trainer kit, so I will be doing the experiment in another. Okay, he will be letting you people to go with the other trainer kit. Okay, so basically how to check whether these wires are in good condition. We have two colors, one is red and black. There is no difference between the red and black wires, both are one and the same. So first you need to switch on this power. Okay, first make sure that look at this trainer kit, look at this here there is a continuity check. Okay, you can just connect here and connect here. If the light is on, this working is properly. If the light doesn't on, then there might be a damage with the wire. So make sure that before starting an experiment, check all the wires which you have got, and so it will be so you'll be more confident. Okay, so after doing the experiment, if you don't get the output, it will be very difficult for you to find out which wire is damaged. So before starting the experiment, make sure that check all the wires like this, connect from here to here. If the light is on, the wire is working properly. That's it. Okay, and let me go then. Okay, I just told this is a 14 pin IC, right? One side 7. Okay, another side 7. So two sides 7. Okay, this is a basic kit. So one side 7, another side 7. So you need to, before inserting this IC, make sure that always turn off your trainer kit, then insert the IC, then make the connections, check it twice. If you're confident about the connections, then only you are supposed to switch on the trainer kit. So if you're not confident, if you're not inserted the IC in middle, if you turned on the trainer kit, then there are the possibilities that these ICs will get burned. Okay, so they will get damaged. So they will get eat up, and it might get there are chances it might get burst up. Okay, so make sure that before switching on the trainer kit, you need to make sure that all the connections are proper and IC is inserted properly. So 90% of your students will be done with the proper connections, but so in tension in your examination you will be tensed. So what you people do is, rather than inserting this IC in the upward direction, you will insert the IC in the like this reverse. So if you insert the IC in the reverse manner, definitely your people won't be able to get the output. Okay, always make sure that this U-shaped knob, you can notice this U-shape at the top, so it should be always at the top position. Okay, so you need to insert the IC in this this latch. Okay, so you can notice here we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So each pin, okay, if you insert the latch, so that refers to there will be a connection from 1 to this latch, 2 to this latch, 3 to this latch, like this. So this is 14 pin actually. Okay, so basic gates normally will be of 14 pins. When you go with the experiments, it will be of what 16 pin. Okay, so maximum it will be 16 pins. Okay, so right now I am going to deal with a basic gate, so I am inserting from the top. So I have inserted from the top. Okay, you might have noticed last two are empty. I have left empty last two. So I have inserted from the top. So I am just locking this. This is open. This is locking. If you lock, you can't open this IC. Okay. So right now I have left the last two as empty. So this 8 and 9 won't be having the connections. Look at here. So these two are empty, right? So these two are empty. So 8 and 9 won't be having the connections. If you want 8 and 9 connections, then you remove this latch like this. You insert from the second position. You leave the top two positions empty. top 2. So if you do like this, then 1 and 2, 1 and 16 won't be working properly. I mean, won't be having the connections 1 and 16. Okay, so right now, in order to avoid the confusions, better insert from the top like this, lock it. So now 1, 2, 3, 4, 5, 6, 7 is working. 8 won't be having the connections because last 2, and 9 won't be having the connections. So this 1, 2, 3, 4, 5, 6, 7. Okay, now 10 acts as 8. This is 8, this is 9, this is 10, this is 11, 12, 13, 14. Don't get confused. So I am leaving the last 2 positions. So 8 and 9 won't be having the connections. So this is 7, fine. This 10 acts as 8, 11 acts as 9, 12 acts as 10, 13 acts as 11, 14 acts as 12, 15 acts as 13, 16 acts as 14, like this. Okay. So this is how you're supposed to insert the IC. So normally when it comes to the basic gates, you can notice here 7 will be always connected to ground and 14 will be always connected to VCC. It might be NAND gate, it might be NOR gate, it might be NOT gate, it might be AND, it might be OR. Some basic gates like 3 input NAND gates or like this, some basic gates. Okay. So 14 pin, normally 14 pin ICs, the 7th pin will be always connected to ground. Okay, and 14 pin should be always connected to VCC. So first the thing is, once the IC has been inserted, make sure that first you supply the VCC power connections. Okay, so power connection is 7 should be connected to, look at this, 7 is ground, right? So I have taken a wire from 7, I have inserted the wire here. Okay, and this is ground, black color is ground, so I'm connected to ground. 7 is connected to ground. Okay, so then look at this, 14 is VCC. So 14 is VCC is, so as I have left last 2 positions empty, this 16 acts as 14. So I am inserting this one wire. The other end of the wire is connected to VCC. So this is ground. Okay, this is VCC. Okay, so done. Okay, now let me see this circuit diagram. 1 and 2 for this AND gate access inputs and 3 is the output. Okay, so 1 and 2. So with one IC you can perform 1, 2, 3, 4 operations. Okay, I am just showing 1 operations. Okay, 1 and 2 are the inputs, 3 is the output. Okay, so let me show 1. So 1 and 2 are the inputs, right? This is 1 is connected to input. I just told these are the inputs and these are the outputs. Okay, next 2 is connected to the input because 1 and 2 are the inputs, output is 3. So 3, this is 3, should be connected to output. So I have connected the 3 to the output, not input, 3 output. So 3 output. Okay. So this is 1 operations. So no need to perform all the 4 operations. You can go with the 1 operations now. Like this is basic gate. Now I am going to switch on this. Switched on. Okay. Look at these buttons. So these are both are off. This is on. This is on. This is off. Okay. So you know this AND gate operation, right? You know this AND gate operation. So when both the inputs are 0 and 0, 0 and 0 means low and low, low and high, high and low, high and high. When this is off, we call it as low. When it is on, we call it as high. Okay. So I just told, so when both are off and off, we call it as low and low. Means the first condition, 0 and 0, the output would be 0. So both are 0 and 0, the output is 0. So the light is off, so 0. So next 0 and 1, the output should be low. So this is 0, I am making it as 1. So the output is 0. and next 1 0, this is 1, this is 0, the output is 0. Okay, next 1 and 1, so 1 and 1, the output is 1. Okay, this is how you're supposed to check AND gate. Okay, this is not an experiment. Okay, I'm just showing you the how the basic gates is going to work. So let me make a connection, like check it here. 4 and 5 are the input, 6 is the output. So I'm connecting 4. Okay, I'm connecting to 4 here. This is 5. I'm connecting connections here. What is 6? 6 is an output. Okay, I'm connecting from 6 to the output. Okay, see, this is this wire has taken connection from 1, this wire has taken connection from 2, and this output is taken from 3, and this is 4. I have taken connection from 4. Look at here, 4. Okay, and this wire I have taken connection from 5. Okay, this is 6, output 6. Okay, I've made a second operation here. I'm just switching on. Okay, 0, this is 4. Okay, this 2. I am leaving with the first operation, I'm going with the second operation. 1 0 is remember the AND gate. 1 0 is 0, 0 1 is again it is showing. See, it is switching on. There is some problem with the trainer kit, so it is switching on the light, but it has to be off, right? So in such situations, what you're supposed to do, so make some just press the wires or press the ICs, so then it will go off. So before it was on, now it is off. So next 0 0 is 0, 1 and 1 should be 1. So 1 and 1 is 1. So no, 1 0 is again, it has to be 0, but it is showing high. So just again, see, I am just pressing this IC. Now it went off. This is due to the problem with the trainer kits. Okay, so this is why I always suggest you people to make an experiment by yourself. Okay, so by just looking at this experiment, it will be difficult for you people to understand the concepts. Not concepts. You won't be getting friendly with these trainer kits. In your experiment, you might get tense. So this is how the AND gate is going to work, and similarly with a NOT gate. So NOT gate, this is OR gate. So NOT gate means, so remove this. I will show with a NOT gate. Okay, wait.